Very good afternoon. See here. I'm starting the session. Listen. So today is the last session in our course. So the previous session, very clearly we discussed about collection. So this collection concept is used to hold a set of elements. So to hold the set of elements of same type, we can use the concept collection. Okay, so we can create the collection in many ways. Among those, one way we discussed, that is index by table, or you can say associative array. So this index by table maintains a table. In this table, it maintains elements and indexes. So it maintains the table of elements and indexes. So if you want to work with the numbers, number data type is ready. Okay, online students, please confirm. Are you getting my voice clearly? Please confirm. Okay. Pravalika, please rejoin into the session. Okay, see here. So collection data type is not ready. So define the collection type and declare variable for the collection type. So define the collection type and declare the variable for collection type. So here data type is not ready. To work with the numbers, data type is ready. To work with the characters, data type is ready. Number data type is ready. Varchar2 data type is ready. But to work with the collections, data type is not ready. We need to define our own data type. So like this, we define our own type. So type name is table of element data type, index by index data type. This index by table holds elements and indexes. So what is the element data type? What is the index data type? We are specifying. So for that data type, we declare the variable for that data type. So D is the collection of this collection data type department array. So yesterday we have seen one example. Now I want to cover some more examples. Listen. So define. See. Define a collection. Define a collection type. To hold, define a collection type. To hold department names. So define a collection type to hold department names. Okay. And hold the department names in collection variable. Hold the department names in collection variable and collection and print them. That's it. This is our requirement. So our requirement is we want to define a collection data type. In that we want to hold department names. So hold the department names in collection variable and print them. This is our requirement. So anonymous block we want to define. So write declare begin end. Declare begin end. See, listen. So data type is not ready. So I want to define one data type here. This data type name is department array. So this department array data type we are defining to hold the department names. So data type is not ready. So define the data type, then declare variable for this data type. So right here, type department array is table of. Okay. So here, what we want to hold now, element and index we want to hold. So elements are department names. Okay, like accounts department. Okay, like accounts department, research department, sales department, operations department. These are the department names. So these department names we want to hold in the collection, and indexes we want to hold in the index column. So this collection we want to create. This collection name is D. D collection we want to create like this. This is our requirement. We want to hold department names in the collection. So first department name index value 1. Second department name index value 2. Like that. To refer these elements, we use these indexes. So this one we want to create now. So in this, first column is element, second column is index. Element is which type? Varchar 2 type. That we have to tell here. Is table of element type. Element type is what? Varchar 2 type. Okay. And index is which type? Number type. Okay. So write binary integer. Write binary integer or PLS underscore integer. So index by binary integer we have to write. Okay. Now data type is defined. Our own data type name is department array. Like number data type, like varchar 2 data type, we defined our own data type, department array. For this department array, we are declaring the variable. Now D is the collection of which data type? Department array data type. Okay. Now, in the D, we want to hold the department names. That is our requirement. Observe carefully. You already know department names are there in the department table. I'm setting page size and line size here. Observe. So select star from department we are writing. So here department names are in which table? Department table. These department names we want to hold. That is our requirement. Okay. So here D collection created in the D of 1. We want to hold the first department name, accounting. This we want to hold in the D of 1. So how to retrieve the data you already know. So to retrieve the data, which command we have to use? Select. Select. Okay. So we want to hold. Select star. Okay. Or select what we want to hold, only department names. So select D name. So select D name. Okay. This D name value we want to hold into. If you want to hold this D name value in the X, we write like this. X. But now where we want to hold? In the D of 1 we want to hold. In the D collection, in the 1 index, we want to hold the department name. So the D of 1 we want to hold. So what we have to write here? Department name into D of 1. From which table we are retrieving? Department table. Okay, where? Which department number? Department number 10. So 10th department name is what? Accounting. This accounting will be retrieved now. Observe here what is happening here. Try to understand. See. See here. Just a minute. So department number 10. Department number 10 name is what? Accounting. Or accounts. So that will be stored in the D of 1. So in the D collection, okay, in the first index, that is storing what? Accounting. Like this it will store. So in the same way, department number 20, name is research, we want to hold in the D of 2. In the D of 3, we want to hold another department name, sales. In the D of 4, we want to hold another department name, operations. So here 4 departments are there. If we follow this way, how many select statements we have right now? 4 departments are there. So how many statements we have right now? 4 we have to write. Okay. So D of 1 value, department number 10 value. D of 2 value, department number 20 value. So D of 3 value, department number 30 value. D of 4 value, department number 40 value. Okay, if we follow this way, If 4 departments are there, 4 select queries we are writing. Tomorrow, 50 departments may be there. If 50 departments are there, how many select queries we have to write? 50 select statements. It increases length of code. So this is not good way. Okay. So even if you are using the loop here, listen. So to execute the statement repeatedly, we can use loop like this. You can assume this as I. Okay. So D of I you can take here every time department names are 10, 20, 30, 40. So assume this as J. Okay. So initially J value 10. After that J value 20. Okay. So 10 values we can increase like that. If you want to write any logic, you can write by using the loop. But the problem here is if you use the loop here, performance will be degraded. How performance will be degraded? See here. This is our PLSQL program. This is our PLSQL program. So our PLSQL program will be executed by the PLSQL engine. Our PLSQL program will be executed by the PLSQL engine. This PLSQL engine can execute only PLSQL statements. It cannot execute SQL statements. If any SQL statements are there, okay, those SQL statements will be submitted to the SQL engine. Try to understand. Okay. So observe carefully here. So this is our PLSQL program. So when we write the PLSQL program, our PLSQL program will be submitted to the PLSQL engine. This PLSQL engine can execute only PLSQL statements. It cannot execute the SQL statements like select, insert, update, delete. Those cannot be executed by PLSQL engine. Those will be executed by SQL engine only. Okay. So PLSQL submits that to the SQL engine, and SQL engine gives result to the PLSQL engine again. So like this, every time PLSQL is sending SQL queries to the SQL engine is giving result to the PLSQL engine. If we follow this way, all these 4 are SQL statements or not. So this first select statement, okay, we are submitting to the PLSQL engine. PLSQL is submitting that to the SQL engine. SQL engine is finding 10th department name and giving it to the PLSQL in the collection that is holding. So like this, here 4 times we are writing select query. So 4 times it has to go to the PLSQL engine to SQL engine to the PLSQL engine. So number of travels will be increased here. If number of travels are increased, automatically performance will be decreased. So to improve the performance, instead of following this way, if you write like this, okay, is it give output, sir? Yes, definitely it will give output. No problem. Okay, observe here. Let me run like this. For I in. Okay, I want to print this department names. So I in. So D dot first means lowest index value to access 1. D dot first means 1. D dot last means highest index value 4. D dot first means lower index value 1. D dot last means highest index value 4. Loop, end loop. Loop, end loop. Okay. So here we want to print department names. So write like this. DBMS underscore output dot put underscore line. Okay. So we are printing the department names like D of I dot. Yes, just a D of I. That's it. Just a D of I. Okay. So now observe here. This is a program to hold the department names and printing them. So set server output on here. So set server output on. And I'm setting verify as off. Set verify off. And I'm clearing the screen. Observe, I'm copying this. Okay. So is it giving all department names or not? Yes, it is giving. Our program is working perfectly. But this is not good way. If we follow this way, okay, so tomorrow if 50 departments are there, 50 select statements we have to write. And if we write like this, even if less departments are there, if we write like this, performance will be degraded. So to improve the performance, they introduce. So in the above example, okay, so select query has written for many times. So if number of requests are increased, then performance will be degraded. Performance will be reduced. If number of requests are increased, then performance will be degraded. Okay, so to avoid this problem, to avoid above problem, to improve the performance, to avoid above problem. So the problem here is select query we are writing many times. Okay, that is one problem. And second problem is performance will be degraded. So to avoid above problem, what we are doing? So we use bulk collect. Bulk collect class we use to collect all values at a time. So the same program I'm copying here. Same program I'm copying. So instead of writing select query for many times like this, so simply here what we write is select what we want to get, department name. Okay. So all department names at a time we want to collect. So simply we have tried which clause here? Bulk collect. So select a department name, bulk collect. Okay. So all department names will be retrieved and all those department names we want to hold in which collection? D. Into D. D is the collection. D can hold set of values. From which table we are retrieving? Department table we are retrieving. Okay. So now see here. Okay. If you write like this, we need to write many select statements. Or even if you use for loop, performance will be degraded. Okay. So if we use bulk collect here, so code length decreased here as well as performance is improved here. So this is the advantage we are getting with the bulk collect. So bulk collect improves the performance. So what is this bulk collect? So bulk collect, it collects all rows and stores into collection. It collects all rows at a time. And stores into collection. So with this, what is the advantage we are getting here? So it reduces number of requests. So performance will be improved. Now. So now observe here, if we write bulk collect, what is happening? We are submitting this select bulk collect statement to the PLSQL. So PLSQL is submitting that request to the SQL engine. How many requests? Only one request. With one request, it is collecting all department names and storing in the D. So with one request, we are collecting all department names. So number of travels between PLSQL engine to SQL engine reduced here. Number of requests reduced here. So automatically performance will be improved. So this is important for the interview. If anyone is asking what is bulk collect, what is the purpose of it means, simply you can say it collects all rows at a time from the table and stores into the collection. So with this, what happens? It improves the performance. Number of requests to the SQL engine will be reduced. So automatically performance will be improved. So to improve the performance of data retrieval, we use bulk collect. So this bulk collect improves the performance of data retrieval. So this is the main advantage we are getting with this bulk collect. That's it. So now, is this program working or not? Just observe. I'm copying this. See here. So all department names are printed. Observe here. So all department names are printed. So what is happening here? See the execution process. Here, we want to create one D collection. In that, we want to hold the department names. So data type is not ready. So we are defining our own collection type. This data type name is department array. So for the department array, we are creating one variable. It can hold varchar 2 type elements and index is integer type. Okay. So this select query will be executed now. Because of bulk collect, all department names will be retrieved here and stored into the D. So now D collection stored with all department names. So here element index. Okay. So first, so all department names it is collecting. Because of bulk collect, all department names it is collecting and storing in the D. First department name is accounts, stored in the 1 index. Second department name is research, stored in the 2 index. Third department name is sales, stored in the 3 index. Fourth department name is operations, stored in the 4 index. So now here D dot first means 1. So when I value is 1, D of 1 will be printed. D of 1 means accounts. Accounts will be printed on output screen. Next I value will be increased. I value will become 2. So D of 2. D of 2 means research. Research will be printed. Next I value will become 3. D of 3. Okay. D of 3 means sales. Next I value will become 4. D of 4 operations. Next I value will become 5. 5 is not falling under this range because first index value 1, last index value 4. 5 means that is out of this range. Comes out of the loop. So it is displaying all department names. So yesterday I already told this collection concept is alternative concept of cursor. So it is alternative of cursor. It is alternative of cursor because cursor is having some drawbacks. So because of that reason, we are using this collection concept. Okay. So cursor is having some drawbacks. To avoid those drawbacks, we are using collection concept. So cursor has drawbacks. To avoid those, we use collection concept. So collection purpose, cursor purpose is same. Both are used to hold multiple rows only, table data only. But cursor has some drawbacks. To avoid that, they introduced collection concept. What are those drawbacks we discuss? So this is an alternative concept of, okay, this collection is alternative concept of cursor. Collection is alternative concept of cursor. Okay. Now my requirement is using cursor we can hold all EMP table records. In the same way, we want to hold all EMP table records in the collection. This is our requirement. Just now we have written one program. Here just we are holding one column data. Only department name column data we are holding in the collection. Now our requirement is entire table data, all records we want to hold in the collection. That is our requirement. Okay. So define a collection to hold EMP table data. So to hold EMP table data, we want to define a collection and hold EMP table data and print them. So hold EMP table data in collection and print employee records. Print employee records using collection concept we want to print. This is our requirement. So instead of using cursor has some drawbacks. So to hold the multiple rows, it's better to use collection. So we want to create one collection like this element. Observe carefully here. Now in the element, we want to hold employee number, employee name, okay, employee job, employee salary, okay, manager ID, okay, department number, okay, hire date. Okay, so like this, entire EMP row, okay, commission value. So like this, entire EMP table row we want to hold now. So this is first row. Index value is 1. So entire EMP table row we are holding. Okay, next another record, 7499. Okay, 7499, employee name is Allen. Okay, so job title is salesman. Okay, so salary. Okay, and he is working in 30 department. So like this, second record index value is 2. So like this, we want to hold all EMP table records. So element is what? EMP table row. So EMP table entire row we want to hold. Now you tell me what is the element data type here? Row type. EMP table row type. So element data type is what? EMP table row type, because we want to hold entire row. Okay. And this is index. Index is binary integer. So now this element is which type now? EMP table percentage row type. So element type is EMP percentage row type. Index type is binary integer. So define collection data type is not ready. So to hold the employee records data type is not ready. We have to create our own data type. Okay. So now first define the data type here. Then declare variable for the data type. So what we have to write here? Declare begin, end. Okay, data type is not ready. So we are writing like this. Type name. So I am giving type name as EMP array. EMP array is table of. Okay. So in the EMP array type, in the table, okay. So what is the element type here? Element type is EMP table row type. EMP table entire record we want to hold. So EMP percentage row type. Okay. Index by binary integer. So here we are defining our own data type. It can hold the EMP table entire row index. Declare one collection, E. Which type? EMP array type. Now E can hold the EMP table entire row. Okay. So right here, right like this. Select star. We want to get a complete data from the EMP table. So select star. Okay. For our convenience purpose, we are writing star. Implicitly, the star will be replaced with all column names, employee name, number, employee name, job, salary, etc. So entire data we want to collect at a time. All rows we want to collect. So what we are writing here? Bulk collect into. In which collection we want to hold? E. From which table we are retrieving? EMP. That's it. If this bulk collect is not there, we need to write many select statements. For loop we have tried. Okay. So this bulk collect improves the performance. It is collecting all EMP table data and storing in the collection. So at a time it is collecting all rows and storing in the collection E. So like this, now this table is created because of this select statement. This table is created now. In the table EMP data holded, EMP data copied here because of this select statement. So entire EMP table data retrieved and copied into E. So now E has total EMP table data. So now this is row type. If we want to access this employee number, what we have right now, this collection name is what? E. Okay. So E. Okay. First employee, right? First employee. First employee means E of 1. E of 1 dot. This is what employee number. So E of 1 dot employee number we have tried. If you want to access this name, what we have tried here? E of 1 dot E name. If you want to access this salary, what we have tried? E of 1 dot salary. E of 1 means Smith. First record. First index record. Okay. So like that, if you want to access this employee name, what we have tried? E of 2 dot E name. If you want to access this salary, what we have tried? E of 2 dot salary. Like this. So like this we have to access. So we want to print all employees records. So assume index value as I. Assume index value as I. Right? For loop here. For I in starting index. So starting index of this collection is E dot first. Last index is E dot last. Loop. End loop. End loop. Okay. To print the data, what we are writing? DBMS underscore output dot put underscore line. We want to print employee name. Okay. So E of I dot E name. So when I value is 1 here, when I value is 1, E of 1 dot E name means first index has first row. So this first index name will be accessed. So E of 1 dot E name, E of 1 dot salary. So this salary will be accessed. So here we are assuming index as I. So 3 spaces we want. Then E of I dot salary. E of I dot salary. Like this we have tried. So you can access remaining data also. Okay, for example purpose, I'm printing only employee name and salary. If you want to access remaining also you can access, no problem. So I'm copying this. Observe here. See, I'm copying this data. See here. So it is printing all employee records. Observe here. All employee records it is printing. See here. Employee name, salary. Employee name, salary. Employee name, salary. Like this. So whatever the task we can do by using cursor, that we can do by using collection. Okay. Cursor performance is low. Collection performance is high. To improve the performance, we are using the collection concept. In the cursor chapter, many programs we discussed. All those programs we can do by using this collection concept. Now, last example on collection. Listen. Last example on collection. Try to understand. There is one table is there. This program already we did using cursor concept. The same program we want to do by using collection concept. There is one table is there, EMP1 table is there. It is having employee details like employee number, employee name, job, salary, etc. Okay. So like, let me check the EMP table data. Select employee number, E name, job, salary from EMP. So from 1001 to 1005, from 1001 to 1005, this data I want to hold in another table. So I want to create EMP1 from 1001 to 1005. So 1004, 1005. So already data is there in the EMP table. From the EMP table only, I want to create this EMP1 table. Okay, what we can write from the, to create from existing table, what we can write? Create table emp1 as select employee number, e-name, job, salary from emp where employee number in, you can give this, or employee number between, and also you can give employee number between 1001 to 1005. Okay, so we are creating emp1 table from the existing table now. So drop table emp1. So we are creating fresh emp1 table here. So this is the emp1 table. Okay, so sorry, and not to, and right, 1001 and between and. Okay, so table is created. So select star from emp1, and we want to create one table, hike table here. We want to create one table, hike table. This is hike table. Hike table, in the hike table we are maintaining employee number, how much percentage we want to increase. That percentage we are maintaining here. For 1001 employee, we want to increase 10%. For 1002 employee, 20%. For 1003 employee, 15%. For 1004 employee, 12%. And for 1005 employee, 18%. Like this we want to increase. This hike table we need to create. So I am creating one hike table here. So create table. Table name is hike. Okay, employee number. Which data type? Number data type. Okay, employee percentage. Percentage. I am taking this as number. Okay, so now with this table will be created. Okay, so name is already exists. Let me drop the existing table, hike table. So we are creating the new hike table here. So this is the new hike table. Okay, so in this we want to insert the records. So now insert 5 records here. Insert into. Table name is hike. Values. Okay, 1001. How much percentage? 10%. Next, 2, 3, 4, 5. 5 records we want. Okay, next 1002, 1003, 1004, 1005. For 1002, 20%, 1003, 15%. For 1003, 15%. And for 1004, 12, for 1005, 18. So to different employees, different percentage of hike we want to give. That is our requirement. So save this table data. So now let me insert these records. So records are inserted and committed. Select star from emp1. So this is the employee table. 5 employees are there. To these 5 employees, we want to give this much percentage of hike. For 1001 employee, 10% we want to increase. For 1002 employee, 20% we want to increase. For 1003 employee, 15% we want to increase, like this. So this is our requirement. So for this, we write like this. Observe here. So declare, begin, end. So this program already we did using cursor concept. So just like in the cursor, we holded this hike table data. This hike table data we holded in the cursor. In the same way, this hike table data we are holding in the collection. So collection name is H. In the H, hold this entire row of hike table. This index value 1. This row index value 2. This row index value 3. Like this, we want to create one H collection. Element is hike table row. Index is binary integer. Like this, we want to hold. In the previous example, we holded employee table row. Now we want to hold a hike table row. This is our requirement. So to hold this hike table row, so data type is not ready. define the data type here. Type. Okay. So hike array. Hike array. Okay. Is table of. Okay. Element is which type now? Element is which type? Hike table row type. Okay. This one we want to hold as the element now. This one we want to hold as the element. First index, second index, third index, fourth index, fifth index. So this is element. This is index. This is element. This is index. So like this we want to hold. So for understanding purpose, I'm taking like this. Okay. So like this, we want to create one collection. This collection name is H. In the H, we want to hold like this. Now this is element. This left part is element. And the right part is index. Okay, so this is element. And this one is index. Like this we want to create now. So here index 1. Okay, for next one index 2. For next record index 3. For next record index 4. And for next record index 5 like this. So element hike table row we want to hold. So what we have write here? Type hike array is table of. So is a table of element type. Element type is what? Hike table row. Hike table entire row we want to hold. So what we have write here? Hike percentage row type. Okay. So index by binary integer. Index by binary integer. So now data type is ready now. So for this data type, declare a variable, collection variable, H. H is which type now? Hike array type. So in the H, what we want to hold? Hike table data. So what we have to write? Select star entire data, bulk collect entire data at a time collect, and store into which collection? H. From which table we are retrieving here? From hike table we are retrieving. So now according to this hike table percentages, we want to increase. So to update the salary, which command we have to use? Update. Okay, update. In which table we want to update? AP1. Set salary equals to salary plus. If we want to increase 10% salary, okay, what we write here? Salary into 10 by 100. Where employee number equals to 1001, like this we write. But now what is our requirement now? This employee number we want to capture from E collection. So this employee number we want to capture. This index value is what? 1. So what is this one? E of 1 dot employee number. What is this one? E of 1 dot percentage. So this much percentage we want to increase to the E of 1 dot employee number. So instead of writing 1001 here, what we have to write? E of 1 dot employee number. So instead of writing 10 here, what we have to write here? E of 1 dot percentage. So if we write like this, here how many employees are there? 5 employees are there. So for second employee, E of 2. For third employee, E of 3. Instead of writing 5 statements, assume index as I. So specify I starting value and I ending value here. Okay, so here we are writing for loop. So here we are writing the for loop now. So just for loop we are writing. For, okay, E dot first means first index. Dot for variable name I in E dot first dot E dot last. Loop, end loop. Loop, end loop. So like this we write. So here we are updating the query. Okay. This is update query. So when I value is 1, okay, for E of 1 means for 1001 employee, how much percentage will be increased? 10%. When I value is 2, E of 2 employee number, 1002, how much percentage will be increased? 20%. So like that, it executes. But here also, in the for loop, again update command is there, observe. Okay, so update command cannot be executed by PL/SQL engine. So what happens here? Just now I explained. So when for loop is executed for E of 1, update command submitted to the PL/SQL engine. So PL/SQL engine is submitting that to the SQL engine. And SQL engine is returning that value to the PL/SQL engine again. So again, for E of 2, another update command again submits to PL/SQL engine. PL/SQL engine is submitting to SQL engine. So submitting PL/SQL engine to SQL engine, this is called one context switch. We call this as one context switch. So switching between PL/SQL engine and SQL engine is called context switch. So number of context switches will be increased. Means number of travels to SQL engine and PL/SQL engine will be increased. Automatically performance will be degraded. So to improve the performance here, if we write like this, so every time update command we are submitting, so every time it is going to the SQL engine and again it is coming back to the PL/SQL engine, so performance will be degraded here. So first, is it working or not? First check it. I'm copying this. Okay, as of now, this is the table data. We are running this program. So is it increasing the salaries or not? Just to check here. So according to the hike table, just a minute. So first must be declared, it is telling, just a minute. Not E here. Collection name is what? H here. Collection name is not E. I'm sorry. Collection name is not E. H here. H dot first. H dot last. Here also H of I dot percentage. H of I dot employee number. So I'm copying this. As of now, it is working or not? Observe here. Okay. See here. Successfully executed. So for user understanding purpose, if you want to display any message like this, you can display dbms underscore output dot put underscore line. Okay. So salary increased. So salary increased. So how many rows are updated if you want to get that? Okay. There is one implicit cursor is there. To execute update command, implicitly one cursor will be used. That implicit cursor name is what? SQL. So SQL percentage row count. SQL percentage row count. Okay. So SQL percentage row count. Okay. These many rows are updated. Rows updated. So these many rows are updated. Like this we write. So this is the query. So observe here. Okay. So maybe it is not identifying perfectly. Ignore this one. Okay. Salary increased. I'm displaying. You can write like that. You try. Okay. As of now, some problem is there. I'm unable to think that much. Just observe. So salary increased. So, and open and see the table data here. Select star from EMP1. So salaries are increased. Initially, this 1001 employee salary was, observe here, 1001 employee salary was 19,952. 1001 employee salary, 19,952. 1002 employee salary, 21,447. So like this data is there. So is it increased the salary or not? Just observe. So observe here. So 1001 employee salary increased here. Okay. Previously salary was 90,952. 1002 salary is also increased here. 21,447. So now his salary is 37,061. So 2-3 times we run that program. So that's why so much salary increased here. So this is about collections. But here the problem is every time update query will be submitted to the SQL engine. Okay, so if you want to execute all update commands at a time, instead of writing like this, we write like this. We use. So in the above program, the problem is, so in the above program, update query will be submitted every time to SQL engine. So number of requests. So number of requests will be increased. So performance will be decreased. So performance will be decreased. So for this, so to solve above problem, we use bulk bind concept. So in bulk bind, okay, so it is used for submitting. It is used for submitting, okay, bulk update commands. It is used to submit bulk update commands or bulk insert commands or bulk delete commands. So this bulk bind is used for submitting multiple update commands, multiple insert commands, multiple delete commands to the SQL engine. So it is used for submitting bulk update, bulk insert or bulk delete commands. So for bulk bind, we will not use any bulk bind keyword here. So for bulk bind, we use for all loop. For bulk bind, we use for all loop. For all loop we use. So to use the syntax, so syntax of for all is, don't write any space between for and all. We write like this: for all variable name. Okay, so lower value dot upper value. Okay, and don't write any loop, end loop here. Directly write whatever the DML command we want to submit. The DML query we write here. Don't write any loop, end loop here. This is the syntax we have to write. If you write update here, this is bulk update. If you write this query as update, this is bulk update. If you write delete here, this is bulk delete. If you write insert here, bulk insert. So this is called bulk bind. So this bulk bind improves the performance. So it improves the performance. So instead of writing the program like this, simply you can use for all. So for all we are writing means this is called bulk bind. And for all, don't use loop, end loop here. Just we are writing for all here, remove loop, end loop here. That's it. Okay. So here we are using for all here. So this one works faster than previous program. In the previous program, we are submitting for loop. Here we are using for all. So it works faster because all update commands will be executed at a time here. Okay. So what it is telling? Salary increased. So salary increased to all employees. Any user understandable message you can type. So like this, same result it is given. Okay. So like this, to improve the performance, we are using bulk bind. So bulk bind reduces number of requests. So automatically performance will be improved. So bulk bind reduces number of requests. So performance will be improved. Okay. So finally, the point to observe here is for bulk select statements. For bulk select statements, use bulk collect. For bulk select statements, we have to use bulk collect. To submit a set of select queries, instead of writing many select queries, we are using what? Bulk collect. Okay, so instead of submitting update query for many times or bulk insert for many times, or bulk delete for many times, simply we are using what? Bulk bind. So bulk bind we are using. For bulk bind, we will not use any bulk bind keyword here. Bulk bind means we use for all. For all we are using means this is called bulk bind. So all update queries will be submitted at a time to the SQL engine. So automatically it improves the performance. So this is about bulk collect and bulk bind, and this is about collection. So collection topic is over. So sometimes interviewers may ask like this: what are the differences between cursor and collection? This is the most common important interview question. So collection is the alternative concept of cursor. What are the differences between cursor and collection? They may ask. So left side, I'm writing points on cursor. And right side, I'm writing points on collection. So the difference here is cursor fetches row by row. Cursor fetches row by row. So when first time fetch statement is executed, it accesses first row. Okay. After that, when fetch is executed for next time, it accesses second row. Like that, row by row will be accessed. But whereas collection, it collects all rows and copies into collection. It collects all rows at a time and copies into collection. This is the difference. Collection is collecting all rows at a time. But cursor, it is fetching row by row. And another difference is cursor can move forward only. Cursor can move forward only. It cannot go backward. It cannot go backward. We cannot go backward again. So in collection we can move forward or backward. Forward or backward. No problem. So observe, try to understand. Here, this is EMP table. Try to understand. EMP table. First row, 1001A, 1002B, 1003C, like this. If it is collection, when fetch is executed, first row will be accessed. When again fetch is executed, second row will be accessed. Now, after accessing second row, I want to access first row again. Can I go back like this? No. The cursor we cannot go back. So when fetch is executed, next row will be accessed. Again fetch is executed, next row will be accessed. After accessing second row, if you want to access first row, can you go back? No. Fetch means it goes to next only. It moves forward only. It cannot go back. But whereas if it is collection, you're using index 1, 2, 3. Okay. E of 1 means first record will be accessed. E of 3 means direct third row will be accessed. Okay. After accessing E of 3, I want to access E of 2. You can access. You can go back. Using index, you can go back here. Okay. So we can move forward. We can go backward. Using the index, it is possible. And this cursor it supports to sequential accessing only. It supports to sequential accessing. Here only sequential accessing is there. So cursor supports to sequential accessing, whereas collection supports to random accessing. Random accessing. Okay. For example, directly I want to access third row. Here I can use D of 3. Here if you want to access third row, first you have to access first row. Then you have to access second row. Then you have to access third row. Sequential accessing. Okay. So cursor sequential accessing. If you want to access third row, first it access first, then second, then third. Based on the row count value, third row means SQL percentage row count. Sorry. Cursor name is if C1 percentage row count is 3. 3 means third record. 4 means fourth record. Like that. You can access whatever the record you want, you can access. But sequential accessing. After accessing first, it access second. After second, third. Sequential accessing. But here directly you can access third record by using the index. Random accessing. So in cursor only sequential accessing, whereas this collection supports random accessing, and performance wise cursor is slow. Okay, so performance wise cursor is slow. So it has poor performance. Poor performance is there for cursor, whereas here good performance is there. Good performance is there for collection. So if anyone is asking what are the differences between cursor and collection, means cursor fetches row by row. Collection collects all rows at a time and stores into the collection. Okay, so every time it will not fetch. Okay, and cursor can move only forward. It cannot go back. Okay, whereas collection, it can move forward as well as backward. So cursor supports only sequential accessing. If you want to access fifth record, first to 4 you must access. But here random accessing is possible by using the index. So cursor has poor performance. Okay, collection has good performance. So bulk collect, bulk bind, those are there. Okay, with that performance will be improved here. So this is about collections and this is about PLSQL. See. Some of you are asking some doubts. Based on those doubts, now I'm explaining. Listen, try to understand. So some of you asked, how can we identify the duplicate records? So display duplicate records only. So display duplicated records only. This is our requirement. Okay. So this is the most common important interview question. How can you display the duplicated records? Okay. And how can you display the, how can you delete the deleting duplicated records? So this is our requirement. So display duplicate records only. So deleting duplicate records. Okay. See, for example, there is a table is there. EMP table is there or EMP2 table is there. It is having fields like employee number, e-name, salary. For example, here 1A 5000 is there. Okay, 2B 6000 is there and 1A 5000 is there. If if the table is like this, okay, I want to delete this third row here. This is my requirement. I want to delete this third row. This is my requirement. Okay, so by using delete command, how can we delete now? Delete from emp2 where employee number equals to 1. How many rows will be deleted? 2 rows will be deleted. But what is our requirement now? Only third row we want to delete. So this third row only we want to delete. Okay, but here for 2 employee number is same. Can we use employee number now? No. Employee name is also same. Can we use employee name here? No. Salary is also same. Can we use salary here? No. Those are the duplicate records. So how can we delete duplicated record? Okay, so deleting duplicated record. So if we want to delete the duplicated record, we can use row ID. For every row ID is there. So we use row ID. For every row ID is there. For every row ID is there. That row ID we have to use. If you write employee number equals to 1, what happens here? 2 rows will be deleted. Okay, so now let me create this table. Drop table emp2. Okay, so we are creating one table here. So table name is emp2. Employee number type. Employee name, varchar 2 type. Okay, salary, number type I'm taking. Okay, bracket close, semicolon. So I'm inserting some records here. Insert into emp2 values. Okay, 1A, some salary, 5,000. Okay, 2B, 6,000. Okay, next one more record we are inserting. So record is duplicated. For example, if record is duplicated like this, we want to delete one record only. So select star from emp2. So the emp2 table, so this record is duplicated. We want to delete this third record. This is our requirement. So if we write like this, delete from emp2, delete from emp2 where employee number equals to 1 means how many rows are deleted? 2. But what is our requirement? 1 row we want to delete. Okay, so 1 row, sorry. 1 row only we want to delete. That is our requirement. Okay, but it is deleting 2 rows here if we use delete command. So in such type of situations, every row has one row ID. Row ID. So if you want to display all columns and row ID, in such type of situations, you cannot write row ID comma star like this. You cannot write like this. So in such type of situations, give alias name for this table. Here write e dot star. E dot star means e tables all columns. Okay, now it is displaying row IDs. Observe here. This row ID is what? AAA. This row ID is what? AAB. This row ID is what? AAC. Remaining from A to N, all characters are same for every row. Observe here. Last 3 characters are, okay, I'm taking, okay, 2 characters are also same. Just last 1 character is different here. I'm taking 3 characters here. AAA, AAB, AAC. This AAC row ID record I want to delete now. This AAC record I want to delete. So I'm writing like this. Delete from emp2 where row ID we have to use. Row ID like percentage. Okay, AAC. Last 3 characters I'm giving. Like percentage means in the beginning any number of characters that can have. Last 3 characters must be AAC. So now which record will be deleted now? This third record only deletes. If you write like this, only third record will be deleted. But we should be careful here. Sometimes Some other rows also A, A, C will be there. Okay, for example, here N is there. Okay, maybe there O may be there. Or J may be there. So NAAC, JAAC are different. We should be careful here. So as of now here, I'm taking AAC here. Because with AAC, another row is not there. So I'm using like this. We should be careful here. Percentage AAC. Otherwise, we can copy complete row ID also. Copy row ID equals to paste this row ID. I'm copying this. Observe now how many rows will be deleted now. Observe here. Delete from which table? EMP2. Where row ID? Where row ID? Where row ID like. Okay, percentage. In the beginning, any number of characters that can have. Last 3 characters must be AAC, write in capitals. String comparison, case sensitive. Okay, how many rows are deleted now? 1 row deleted. Now 3rd row is deleted. Observe here. Okay, 3rd row is deleted. AAA is there, AAB is there. AAC deleted. Observe here. So how can you delete duplicated record? If anyone is asking, simply you can say use row ID. So for this row ID is AAA. For this row ID is AAB. And for this row ID is AAC. Like this. Okay. So like this we can use. And we want to display duplicated records. So how can we display the duplicated records, sir? Listen. So let me insert some more records in the table. As of now, table has no duplicated records. So let me insert duplicated records here. Insert into. Okay, one more duplicate record we are inserting. One more duplicate record we are inserting. 3C4000. I'm committing the data. Observe here. So select star from EMP2. Our requirement is we want to display only duplicated records. 1, 2 are duplicated, right? Okay. So if we want to avoid the duplicates, we can use distinct. We can write like this. So select distinct star from which table? EMP2. So first row it is displaying, second row it is displaying, third row it is displaying. Every row it is displaying uniquely. But what is our requirement? Which rows are duplicated? Those only we want to display. Third is not duplicated, but still it is displaying. So if your requirement is every row, if you want to get uniquely, use distinct. So every row we are getting once here. So distinct values we are getting. To avoid duplicate rows, use distinct. But what is our requirement now? Only duplicated records we want to find. So to find the duplicated records, we have to write like this. Listen carefully here. You already learned group by. Employee number, e-name, department number, job. From EMP. Order by department number. Within the department number, we are arranging according to the job. Okay. So just a minute. Okay. So observe here. We want to display only duplicated records. That is our requirement. If we write like this, if we write group by department number, what happens? If department number is same, that will be one group. 10th department group, 20 department group. This you already know. If department number is same, that is one group, right? In the same way, for example, we are writing department number, comma job. If department number and job both are same, that is one group. This is 10th, 20 department clerk group. Okay, this is 10th department clerk group, 10th department president group, 20 department analyst group. If both values are same, that will be treated as one group. In the group by we discussed this point. So this is 30th department salesman group. If both values are same, that will be treated as one group. When we write group by department number comma job. If department number, job both are same, that is one group. So this will be given once. If you count it, how many records are there? 3. In the same way, our table is EMP2 table. So select star from table name is EMP2. Observe here. So 1A duplicated here, 2B duplicated here. Only those duplicated records we want to get. Now what we are doing is, we are doing like this. Group by all columns list we are giving. Group by employee number, comma, e-name, comma, salary. All columns list we are giving. So if all these column values are same, this will be treated as one group. Now this is 1A 5000 group. So now, this is what now? This is 1A 5000 group. So this 1A 5000 will be given one time. And this is which group now? 2B 6000 group. And this is 3C 4000 group. Like this 3 groups will be formed here. So here we are grouping the records according to all columns. Okay. So now what we are writing here? Group by, try to understand. Group by employee number, comma, e-name, comma, salary. If you write group by department number, means if department number is same, that is one group. 10th department, one group, 21 group, 31 group. If writing group by job, if job value same, that is one group. Clerk group, manager group, salesman group. If you write group by department number, comma, job, means if department number, job value same, that is one group. 10th department, clerk group. 20 department, manager group. Like this. If these both values are matching, one group. This is 20 department, manager group. 10th department, clerk group. In the same way, here we are writing group by all columns we are writing. So group by employee number, comma, e-name, comma, salary. So now what happens here? If these 3 values are same, that will be treated as one group. Now this is 1A 5000 group. Now this is 2B 6000 group. And this one is 3C 4000 group. So now count them. Apply count function. Apply count function on these groups. So 1A 5000, how many records are there? 2. 2B 6000, how many records are there? 2. 3C 4000, how many records are there? 1. So duplicated means how many records will be there? 2 or more or not? Okay. Not duplicated means only one record will be there. 3C 4000. How many times this record is there? One time only. Duplicated means 2 times will be there or more than 2 times will be there. If count of star value greater than 1 means that is duplicate record. So just we are counting the records here. So we write like this. So we write select. So now the table is, this is a table. So this is the table. And in this, 2B 6000, another record. 3C 4000, another record. Okay. So select all columns we want. So E dot star. You can write E dot star, or you can write employee number, E name, salary. Okay. From which table we are retrieving? EMP. From EMP table. EMP2 table. Sorry. EMP2. Group by. Group by. Now we are grouping the records according to all columns. Okay. So if all column values are same, that will be treated as one group. So now we want to count how many records are there. Having count of star. Having count of star greater than 1. So without having, I'm running this, just observe. Already table is created. Okay. So without having, I'm running this, just observe here. So what it is giving, just observe. So 1A 5000. So let me write count of star here. Count of star, it is not displaying count of star. Okay. So without having I'm running, just observe what it is giving. So observe here, it is grouping the records according to the all column values. So 1A 5000, how many records are there? 2. 2B 6000, how many records are there? 2. 3C 4000, how many records are there? 1. So these are duplicated records. That's why count value 2. So if more than 2 times also there, that is duplicated only. So if count of star value greater than 1 means duplicated. Count of star value 1 means that is not duplicated record. Count of star value greater than 1 means that is duplicated record. So that's why we are writing having count of star greater than 1. On result of group by, we are applying having. So it is displaying only duplicated records. Observe here. And we have no need to display this count. Don't display count. Okay, so now it will display the duplicated records here. So these records are the duplicated records. So we are getting one time. So to identify which rows are duplicated, to identify that, we can write like this. Group by, according to all columns we are grouping, having if count of star value greater than 1 means those are duplicate records. Okay, now our requirement is we want to delete the duplicated records. This is our requirement. So to delete the duplicated records, we must use row ID. Okay, so we write like this. Here we have to use correlated subquery here. For example, assume that let me check the row IDs here. Select row ID, comma. After this query, I stop the session. Listen. So row ID, comma, E dot star from EMP2 E. Okay, observe here AAA, AAB, AAD, AAE, AAF. These are the row IDs. Okay, so AAA, AAB, AAD. Okay, so C is not there. D. Okay, next EF. EF. So like this, these are the row IDs actually. So what we are doing is first select first row. Okay, first select first row. Okay, so select. Sorry, we want to delete the records here. So delete from which table? EMP2. We are giving alias name as E, where we write like this. Row ID not equals to, where row ID not equals to, here we write another row ID, another query here. Okay, so subquery we are writing, correlated subquery. So select, what we have to find is minimum row ID we are finding here. So minimum row ID, so select min of row ID. From which table? EMP2 table. Okay, where? Okay, for which rows? If this employee number and employee name, salary are same, for them we are finding the minimum row ID. Okay, so this is the subquery. What we have to write is employee number equals to outer query. Alias name is E. So this first row will be selected. First row will be passed to the inner query. In the correlated subquery, first outer query will be executed. Outer query passes value to the inner query. So E dot employee number. Okay, and this should be same. And E name equals to E dot E name, and salary equals to E dot salary. Okay, so like this we write. So now what happens here? Try to understand. First row will be selected. Okay, this first row value will be passed to the inner query. Okay, so now here, This outer query row ID value is what? AAA. This inner query will be executed. Okay, so employee number 1. Okay, for the outer query, sorry, E dot employee number 1, E dot E name value A, E dot salary value 5,000. So if any rows are there with these values, it is selecting. So this is selecting this query now. Okay. So now this query value is what? AAD here. Row ID is what? AAD. Okay. And this row ID's value is what? AAA. So 1A, 5,000, 1A, 5,000. So 2 rows are there. So 2 rows will be selected here. In these 2 rows, what is the minimum one? Okay, the AAD and AAE. In the AAA and in the AAD, which one is the minimum one? AAA is the minimum one. So this subquery returns AAA now. This outer query row ID is what? AAA. So AAA not equals to AAA. This condition is false. So this row will not be deleted. Okay, this row will not be deleted. Row will not be deleted. Okay, one more time I'm explaining. Listen. First outer query will be selected. Outer query passes value to the inner query. So E dot employee number value is what? 1. E dot E name value is what? A. E dot salary value is what? 5,000. So this select query, if this condition is true, if employee number, employee name and salary values are true, those rows will be selected. So like that, how many rows are there? These 2 rows are there. 1A 5,000, 1A 5,000. 2 rows are there. So this is 1 row ID, this is 1 row ID. In the row IDs, it will find minimum row ID now. In the AAA and in the AAD, which one is the minimum row ID? A. So this row ID value is what? AAA. So AAA not equals to AAA. Condition false. So it will not delete first record here. First record will not be deleted. So like that, for every row it will execute now. Next it selects which row now? Second row. Now second row value will be passed to the inner query. What is E dot employee number value? 2. What is E dot E name value? B. What is E dot salary value? 6,000. So the records which are having employee number 2, employee name B, 6,000, those will be selected. 2 rows are there. So one is AAB is 1 row ID, AAE is 1 row ID. In this, which one is the minimum? AAB is the minimum. So this inner query returns AAB. And this row ID is also what? AAB. AAB not equals to AAB. Condition false. It will not delete the row. Okay. Okay. So like this. This row will be selected now. Third row will be selected. Listen carefully. This third row value will be passed to the inner query. What is E dot employee number value? 1. What is E dot E name value? A. What is E dot salary value? 5,000. So the records which are having 1A 5,000 will be selected. Means 2 rows will be selected. In the 2 rows, row ID will be selected. In the row IDs, minimum row ID will be found now. In the AAA, in the AAD, what is the minimum one? AAA. Try to understand. Minimum row ID means what we are getting? AAA. What is this row's row ID? AAD. AAD not equals to AAA. Is this condition true? Yes. True. Means this third row will be deleted now. Duplicate row deleting or not? Yes. So this is the way. So here second row will not be deleted. And third row will be deleted now. This is the way. Next fourth row will be selected. Okay, this fourth value will be pass it to the inner query. E dot employee number value 2, E dot ename value B, E dot salary value 6,000. Okay, so in all rows which are matching with these values, those will be selected. Means this second row, fourth row will be selected. In the AAB and in the AAE, which one is the minimum row ID? It finds here. Which one is the minimum row ID? AAB. So AAB is the minimum value. AAB is the minimum value. And for this, what is the row ID? AAE. So AAE not equals to AAB. Condition true. This row will be deleted now. Another duplicated row deleted. Observe here. So another duplicate row is deleted. Next, last row will be selected. This value will be passed to the inner query. So this is 3C 4000. So only one row is there. So this outer query row ID value is AAF. Here it is finding minimum row ID. Minimum row ID is what? AAF only. Only one row is there. So AAF not equals to AAF. Condition false. So row will not be deleted. Okay, so this is the way of deleting, okay, duplicated rows. So if we want to delete many duplicate rows, use correlated subquery. If you want to delete one duplicate row, simply use row ID like this. Okay, so these are the important queries for the interview. Okay, and someone is asked, how can we set the multiple keys as primary keys? So setting multiple keys as primary key. Listen. For example, here one table is there. EMP3 table is there. Employee number, employee name, either. Okay, or otherwise I'm taking customer table here. Customer table. One bank is maintaining like this. Customer ID or account number. Okay, employee name, that employee's Aadhaar number. Okay, employee's PAN number, like this they are maintaining. So we cannot create multiple fields as the primary key. So if we are setting account number as primary key, can we set Aadhaar number as the primary key here? No. Can we set PAN card as the primary key here? No. One table can have only one primary key. One table can have only one primary key. Okay, if we want to maintain unique values here, we don't want to accept duplicate values and we don't want to accept null values here. So at that time, we can write combination of constraints like this. Create table. So table name is customer. Okay, so customer account number type I'm taking. Okay, account holder name, varchar2 type I'm taking. Varchar2 type, and next Aadhaar number type I'm taking like this. So bracket close. Okay, for account number I'm setting primary key here. And Aadhaar number also I want to set primary key. So can we set like this? No, it gives error. So I'm creating like this. If any table is there with the name customer, I'm dropping that one. Okay, I'm copying this and observe here. So observe here. A table can have only one primary key. If your requirement is like this, okay, simply you can write the combination of constraints like unique, not null. Like this you can write. So unique means does not accept duplicate values. Not null means does not accept the null values. So both constraints at a time we are applying on Aadhaar number. Okay, so you can create like this. So table is created. So now when we are insert into, what is the table name? Customer. Okay, sorry. Insert into customer values. Okay, values I'm giving as 1001 A. Aadhaar number, actually we have to give 12 digit number. I'm giving 4 digits here. Just try to understand. One more time I'm giving 1, 2, 3, 4 here. Is it accepting this record? Observe here. Unique constraint violated. So our unique not null is working perfectly. Observe. It is not accepting the duplicate value. And I'm trying to insert null value here. And it is not accepting the null value. So like this, okay, for any number of columns, you can set unique not null. For one table, we can set one primary key only. For remaining columns, if you want to avoid duplicate values and null values, apply unique not null. And if you want to apply, sometimes using one column, we cannot identify the rows uniquely. Last point, with this I stop the session. Listen. For example, there is one table is there like this. Student ID, student name, subject, marks. So student ID 1001 A, in the math subject, he got 50 marks. 1001, same student. Okay, in the physics subject, he got 70 marks. 1001, same student. In the chemistry subject, he got 65 marks. 1002, sorry, same student means same name, right? Same student means same name. Okay, so 1002, B student, in the math subject, 78 marks. 1002 student, same student, means same name. He got 55 marks. And 1002, same student, in chemistry, he got 45 marks. Like this we are maintaining. Now, to identify the rows uniquely, we cannot use SID now, SID duplicated. And we cannot use SName, SName duplicated. We cannot use subject, subject duplicated. And we cannot use marks, marks can be duplicated here. Okay. So in such type of situations, multiple fields we have to set as the primary key. I'm setting SID and subject both as the primary key. If we set multiple fields as the primary key, if individually this 1001 is duplicating, it accepts. If individually mass is duplicating, it accepts. But if combination of 1001 and math is duplicating, this duplicate record will not be accepted. And if you are inserting null here, null will not be accepted. If you are inserting null here, null will not be accepted. Here, both fields are acting as the primary key here. If both values are duplicating, it will not accept. Individually, 1001 is duplicating, it is accepting. Individually, if mass is duplicating, it is accepting. 1001 math already you have given. If 1001 math we are giving means it gives error. This is creating duplicate record here. Okay. So like this, if you want to set multiple fields as the primary key, that is called composite key. Composite key means, composite primary key means more than one field serves as primary key. That is called composite key. So to create this table, we write like this. Create table. If the table name is student. Okay. First field is SID, number data type. Second field is SName, varchar2 data type. And third field is subject, varchar2 data type. Third field is subject, varchar2 data type. And fourth field is marks. Okay, marks number data type. So sometimes using one field, we cannot identify the rows uniquely. So at that time, we write like this. We write table level constraints. So table level constraints, we write like this. So constraint name I am giving as CX. So constraint name, primary key. So primary key we want to apply to SID column and subject column. So SID and subject both acts as primary key now. So table level constraint we have to define. If you want to apply multiple fields as the primary key. If individually SID is duplicating, it allow. If individually subject is duplicating, it is allow. If combination is duplicating, it will not allow. 1001 mass already given. If you write 1001 mass, it will give error. Okay. So like this, we create composite key. Generally, in real time, mostly they try to avoid composite keys. Okay, so forcibly they add one more key here and they apply serial numbers here. Like this, they add one more row forcibly, one more column forcibly, and they identify the rows uniquely, generally. But if required, we can set composite key like this. This is called composite key. Okay, observe now. So if any table is there with the name student, I'm dropping that one. Okay, no table is there. So we are creating this table. Okay, observe here, table is created. Let me insert the record here. Insert into table name is student values. Student values. I'm giving values as 1A. Subject is maths. Okay, 1A maths 60 I'm giving. So observe here. If I am giving 1A physics here, is it accepting or not? See, accepting. If I am giving 2B physics, so 2B or maths I am giving. 2B maths I am giving. So maths is duplicated now. Okay, is it accepting or not? Yes. So open and see the table here. Select star from student. So individually student ID duplicated, it is accepting. Individually subject is duplicated, it is accepting. Now one more record I am inserting. Student ID 1, math already inserted. One more time we are inserting 1 math here. So now it gives error. So 1 math I am giving. Okay, even if you are giving different name, it will not accept now. Now this record will not be accepted. Unique constraint violated, it is select. Because 1 math, both are duplicated or not, it is checking. So 1 math already there. Again you are giving 1 math. So combination, it is working as the primary key. And both will not accept null values. If you try to insert null value here null value will not be accepted. Okay, cannot insert null. And here also null value will not be inserted. Both will not accept the null values. So this is about composite key, and this is about SQL and PLSQL, and this is about your course. So we started our course on April 27. On April 27, we started our course. So today is July 23. So almost all 3 months. Okay, nearly 3 months. We discussed clearly about SQL and PLSQL. Okay, so thanks for your cooperation and thanks for your regularity. All the best for your bright future. Okay, bye everyone.